All right, this problem is for you to try. I just made this one up. I didn't choose one from the homework because there weren't any in the homework that had exactly what I wanted to go over in this video. This is actually very similar to the last problem. We're using a sum formula for tangent. I'm adding together these two things. I might just choose to call them theta 1 and theta 2 to remind myself that inverse trig functions spit out an angle. Now, in the last video, we were using the sum formula for tangent, and we were given some information about the two angles. We were given one of the trig values, and then some information that told us what quadrant we were in. That's exactly what we have when we know that an angle is an inverse trig function of some number. That tells us one of the trig values of that angle, and it tells us what quadrant we're in. Okay? So, pause the video, see if you can work this one out and fully simplify it. I have rigged this so that the numbers aren't going to be too horribly atrocious. Okay, see if you can work that out and then tune back in and we'll go through it together. All right, I'm going to start by just writing out what the sum formula is for tangent. And because I've given these two angles nicknames, I'm just going to use those nicknames because that's going to be a lot less writing for me. So I'm going to say that this is going to be tangent of theta 1 plus tangent of theta 2 over 1 minus the product, tangent of theta 1 times tangent of theta 2. Okay. So I basically need to find two things so that I can replace all of these things with numbers. I need to find tangent of theta 1 and tangent of theta 2. So let's work with theta 1 first. Okay. So if theta 1 was arc sine of negative 3/5. What that tells me is that sine of theta 1 is negative 3/5, negative 3/5, and theta 1 is in the interval from negative pi over 2 to pi over 2. That's the range of arc sine. Okay. Now, of course, that corresponds to quadrants 1 and 4, but that's a negative number. And sine is going to be negative in quadrant 4. So I know that we're talking about an angle that's in quadrant 4. Okay. I can draw myself a picture. Theta 1 is just going to be a negative acute angle. So if I'm trying to figure out tangent of theta 1, well, we're in quadrant 4. Tangent's negative. Okay. Now, I'm going to let alpha be the reference angle. That would just be that same acute angle, but counted as positive. So it's the opposite of theta 1. Okay. And I know, of course, that sine of alpha is the absolute value of negative 3/5. So it's just positive 3/5. So there's a 3 and a 5. Now, this time I'm saying a 3 and a 5. Pythagoras is going to make that last sign a 4. Okay. If I didn't remember that, I could have called it a for adjacent and said a squared plus 9 equals 25, but then a squared equals 16, and so a is positive 4. Okay. So then I can say, okay, the absolute value that I'm going to attach to that negative sign is tangent of my reference angle. That's opposite over adjacent, that's 3/4. Okay. So tangent of theta 1, is negative 3/4. Okay, so I'm going to have negative 3/4 plus, we've still got to figure out tangent of theta 2, over 1 minus negative 3/4 times we've still got to figure out tangent of theta 2. Okay. All right, now theta 2 was equal to arctan of 5. Now that tells me two pieces of information. Tangent of theta 2 is 5, and theta 2 is in the open interval this time, from negative pi over 2 to pi over 2. That's what I need. This is very nice. When I take tangent of arctan, I'm composing inverse functions. Arctan is guaranteed to spit out an angle that's in that restricted, that's in the range of arctan, which is the restricted domain, so that when I'm applying tangent, I am actually composing inverse functions. Where I have to be careful is if I'm plugging into tangent first and then plugging into arctan, because then I could plug in an angle that's outside of that range. Okay. So this is just going to be 5. Nice. So let's see what we have. We've got -3/4 plus 5 over 1 plus, because those two negative signs will cancel, and that's just going to be 15/4. Now this is kind of nice. There aren't any roots for me to worry about, but I do have complex fractions. Simplest way to get rid of that is to multiply by 1 in the form of whatever I want to cancel over itself. And it looks like what I want to cancel is a 4. If I had two different numbers here, I'd take the least common denominator, the smallest thing that would cancel all of them. But here, that's just 4. And so when I distribute that, it's going to cancel here, so I'll get -3 plus 5 times 4 would be 20. And then on bottom, 4 times 1 gives me 4. Plus here it cancels, so I get just 15. Excellent. That's going to give me 17/19. And so that's our answer.